All right, PreLab for column chromatography. In the column chromatography lab, we do column chromatography is basically a larger scale of the TLC you ran last week. So in thin layer chromatography, the stationary phase is really small, really thin, and the amount of material we analyze is really small. So we're not trying to purify a large amount of sample. We're just trying to kind of get an idea of what's in the sample, and we'd like to use as little of that sample as possible. In column chromatography, we're trying to use the entire sample and we're trying to purify, actually physically separate components of a mixture. So let me share my screen. There you go. You can see the PowerPoint. Now, go on to the next one. There. Okay. So remember from TLC, the stationary phase is the part of the system that doesn't move. In TLC, that in the TLC we did last week, that is silica gel or silicon dioxide. The mobile phase was an organic solvent. And in that system, the less polar a compound is, the faster it would move because it would spend more of its time in that nonpolar organic solvent. Right? The organic solvent's constantly moving. And so the more time, the compound's kind of bouncing back and forth. Stationary phase, mobile phase, stationary phase, mobile phase. When it's in the mobile phase, it moves. When it's in the stationary phase, it just stays there. So a less polar compound that doesn't interact with the silica gel well will spend more time in the mobile phase and it will move faster. A polar compound, a more polar compound that interacts better with the stationary phase will spend more time in the stationary phase not moving, and therefore it moves overall more slowly. Okay, so again, if you remember in the TLC, you start the sample where my cursor is, put the plate into some organic solvent, capillary action pulls the solvent up the plate. So the least polar compound moves really fast. B, kind of a middle polarity, moves middle, and C, the more polar compound, moves slowest. We're going to turn that on its head in column chromatography. Okay, so in column chromatography, we're going to have a column of silica gel, and we're going to load the sample at the top of the column and let gravity move the solvent. Right. So now, if you think about, we really should have had A, B, and C on this one, but if you think about it, the less polar compound again spend more of its time in the mobile phase. It's going to move through the column faster. So B here is the least polar compound. You put A and B on at the top, they start moving. A stays in the stationary phase more often, so it's up here it's closer to the top, moving slower. B is rushing forward, B, which is less polar. And then B will actually elute at the end of the column, purified, hopefully. And you can collect it. So what you're doing is you're basically moving test tubes. Sorry, I can't see my hands. You're moving test tubes at the bottom of the column. So as solvent elutes off the column, you collect it. And so you ideally get B in a test tube, and then a few test tubes later, you get A in a test tube, and you've separated A and B physically. So just some warnings about the lab. Silica dust is hazardous to the lungs. You probably have not heard of silicosis, but maybe you have. You may have heard of miner's lungs. Really, any small particles that can be inhaled into the lungs that are sharp are really dangerous. And so, honestly, we've probably never done the column chromatography lab more safely than we'll do this semester with you guys wearing masks. It's a good idea actually to wear a mask anytime you do a column. Every lab I've worked in, if you go over to where the silica gel is kept, there's usually an N95 mask there. It's not very sanitary, but like everybody uses the same N95. I don't even usually put it on. I just hold it over one hand, scoop out the silica with the other. You guys won't be using it on that scale, but you should remember to keep the silica in the hood. Don't spill it. Don't throw it around. Don't agitate it. It's really fine. These are really fine particles, and the particles themselves, not to your skin, but to your lungs, are sharp. Right? They're jagged particles. So anyway, you guys can hit pause there and read these safety columns. Um, you're gonna need to wash glassware at the end. Uh, Me and the TA will help you out getting this stuff set up. But you should definitely have that in your notebook when you come. All right. All right. So the way this experiment's going to go is we're going to start out with we're going to use Excedrin. So we used aspirin last week. We're going to use Excedrin this time, and Excedrin's got aspirin and caffeine in it. Good stuff. Um, you're going to analyze it by TLC, just like you did last week. You're going to see the aspirin and the caffeine. And then you're going to do the column, right? And again, C is going to move more. C on the TLC is at the bottom because it moves slower. Remember, in the TLC, the solvent's moving up. In the column, the solvent's moving down. So C is going to, it's just, the column is just going to be an upside down TLC plate, basically. So C is going to hang out up here at the top. B will move in the middle. And then A, being least polar, will move fastest. And you'll collect them in test tubes. And if you run a TLC on those test tubes, what you hopefully will see is, test tube. There'll be a test tube with only A, won't have B and C in it. There'll be a test tube with only B, won't have A and C in it, and then there'll be a test tube with only C in it. The solvent we're going to use. So the mobile phase in an organic laboratory, the mobile phase is almost always nonpolar organic solvent. So hexane is the least polar. We use hexane. It's easy to remove by distillation. We'll talk about that in a minute. Typically, hexane and ethyl acetate are the two solvents you use. Hexane is extremely nonpolar. Ethyl acetate for an organic solvent is fairly polar. The carbonyl is polar, and it's miscible with hexane. So it's not ethyl acetate's not polar like water, but we can't use water, right? Water is going to dissolve silica gel. Silica dissolves in water. Water is not miscible with hexane, so the polar organic solvent is going to have to be something like ethyl acetate or acetone. There's the ingredients of Excedrin. Oh, it's got acetaminophen in it too. I knew there was a reason. By the way, since I don't get to do this in person, you guys, if you're not aware, acetaminophen is toxic and you can easily overdose on it. So if you like munching Tylenol, you guys are young, you don't hurt most of the time. I'm not trying to make it sound bad, but I threw my back out over the weekend again. And anyway, ibuprofen's your friend. If you like Tylenol, if you have COVID right now, Tylenol might relieve symptoms. Don't take too much. Take the dosages seriously. Okay, Excedrin has acetaminophen, aspirin, and caffeine in it. We're going to separate those on column. So you're gonna grind them up. Put that stuff. You've got a procedure that is going to describe to you how you should load these on the column. So when you come in the lab, prepare your column, load the Excedrin on the top of the column. You're going to push solvent through the column, following by TLC. Right? TLC is the workhorse analytical technique for organic chemists. So you're going to analyze each fraction as they elute off the column, and then once you identify where the aspirin is, we're going to isolate the aspirin. So step 3 there is remove solvent from the fraction containing aspirin, and we're going to remove the solvent by evaporation. More on that in a second. All right, so you're going to check the mass recovery of the aspirin, and you can check the purity of all the materials using TLC. So this is not how your column's going to look. All right, this is what a column looks like. So you're going to clamp it there in a pipette. The column's just going to be this little pipette. In this column, we've put colored material in, right? So whatever the green stuff is, it's more polar than the blue stuff. The blue stuff moves faster through the column. The green stuff moves slower. You put a little bit of cotton here in the column, right? So this is a pipette, a close-up of a pipette. If you don't put this little plug of cotton there, when you pour your silica gel in, it'll just like flow through the pipette and go out the bottom. So you got to have something there to hold the silica gel in. And you're going to push the solvent through with a pipette ball. You'll figure that out once you get in. Again, you're going to use TLC to check what's in each fraction. You can use one spotter. You only need to use one spotter. You need two TLC students, TLC students, two TLC plates per student. And then you're going to get a TLC plate that looks something like this. You can co-spot with pure material, so the aspirin's going to run fastest, then acetaminophen, and then caffeine. The polarity is a little weird, right? Aspirin is actually a fairly polar molecule. It's got a carboxylic acid in it that can hydrogen bond. This acetate hydrogen bonds all right. Caffeine turns out to be more polar. Uh, there's no there's no hydrogen bond donor, but there are one, two, three, four hydrogen bond acceptors. And so caffeine actually sticks to silica really well. And as I said, in the end, you're going to remove the solvent from the aspirin fraction with a rotovap. There's a picture of our rotovap. You put a round bottom flask down here. We haven't covered distillation yet, but what happens is you spin your flask. That effectively increases the surface area of the fraction. As you increase surface area of a liquid, it evaporates faster, right? Evaporation is molecules in the liquid escaping into the gas phase. That's faster if there's more gas phase exposed. And the other thing a rotovap does then is we lower the pressure over that liquid. So liquids boil lower at a lower temperature at lower pressure. And so this hose here is hooked up to something that generates a vacuum. It's a low, it's not a super high vacuum, but it gets the job done. And then there's a water bath here that you can actually supply some heat to if you need to heat the solvent a little more. You'll get instructions in the lab from me or the TA about using the rotovap. Okay, so next week you need to show up with your lab notebook filled out, ready to take the lab quiz, pre-lab quiz. And then you need to do the lab. Your report will be due 3 days later on Friday. If you are, so those of you in 2021 seeing this, if you're quarantined or isolated the day you're supposed to come in, there'll be an optional assignment for you, but you should still take the pre-lab quiz. I think that's it. All right, cheers. See you in lab. In slideshow. This is always an awkward phase. Stop recording.